This is a review of the gas laws that you have to know for this unit. First, let's start out with some important information. First off, standard temperature and pressure, which we'll talk more about later, is 273 degrees Kelvin, or 273 Kelvin. That's the same as 0 degrees Celsius, and 1 atmosphere, which is the same as 760 millimeters of mercury, or 760 torr. And I also wrote that here. Also notice that 1 atmosphere is equal to 101.325 kilopascals. These are all units you have to be familiar with, and they're all units of pressure. So as we do practice problems, you want to be familiar with these units. Dalton's law, total pressure is equal up to partial pressures, just combined. Boyle's law relates pressure and volume. Charles' law relates volume and temperature. Gay-Lussac's law is relating pressure and temperature. Combined gas law takes these three laws that we just mentioned and puts them all together, which is probably the most useful one. And then the last one is this conversion of Kelvin from Celsius. So if you're ever given degrees Celsius, be sure to convert to Kelvin first. You have to convert to Kelvin. We don't have to worry about pressure as much, but Kelvin is something that's the standard you want to keep with. So if you're ever given Celsius, convert it to Kelvin. Let's do some practice problems. This is a really simple one, just converting pressure to different units. So we're given pressure in atmospheres, and we just got to convert that to millimeters of mercury. So there's a couple ways you can do this. I'm going to do it the way we started at the beginning of the year doing. So I'll put atmospheres on the bottom because I want that to cancel out. The conversion, it was on the previous page, again, was for every 1 atmosphere, you have 760 millimeters of mercury. So I'm going to put 760 up here because I want to go to millimeters of mercury. I want my atmospheres just 1 to 760. That's going to cancel out. And if you do the calculation, you get your answer. Just multiplying 840 times 760 and then divide by 1. This will give you 0.638 millimeters of mercury. Or excuse me, it's actually, the answer actually comes out to 638.4 millimeters of mercury. That's the answer you get. Moving on. So this problem is a little more complex. Sample of oxygen occupies 560 milliliters. That is a volume. So you can immediately write out that your volume is 560 milliliters. When the pressure is 100 millimeters of mercury, so you can immediately write out what your first pressure is. And I really encourage you to write out the units as they're given to you. At a constant temperature, so your first temperature is just constant, what volume does the gas occupy when the pressure decreases to 700? So our volume is what we want to find out, and they're telling you that the pressure decreases to 700. So notice here that they just told you temperature is constant, so that's not really a factor. So you want to find the equation that relates volume and pressure. Your best option for that is Boyle's law. All right, Boyle's law, again, was P1 times V1 is equal to P2 times V2. And if you look at how I set this up here, you can just plug these right in. So it just becomes 800. And you know what? Let's do the units with this. So it's 800 mmHg times your V1, which is just 560 milliliters. That's equal to your P2, which is just 700 mmHg times what we're going to find, V2. So all you have to do is just solve for V2. So when you multiply these first two numbers, 800 times 560, you'll get something like this, equal to 700 times V2. divide each side by 700. That will give you 640. And just stick with the same units. So if V1 was in ml, then V2 is also going to be in ml, or milliliters. So let's try another one. So on a winter morning, when the temperature is -3 degrees Celsius, so we'll say T1 is, or excuse me, -13 degrees Celsius, the air pressure in an automobile tire is 1.5 atmospheres. So let's write that out. If the volume does not change, so your volume is constant, what is the pressure after the tire is warmed up? So your T2 becomes 15 degrees C, and they're asking you to find P2. You don't know. So again, volume's constant, it's not a factor here, so you gotta find something that relates pressure to temperature. So that's the Gay-Lussac law, so we need this law, which is P1, T1 is equal to P2 over T2. That's what we have to go with here. So in this case, you can just plug them right in here. So 1.5 atmospheres divided by T1, which is, oh, before I do that, I gotta convert to Kelvin. So my T1, all right, so when you do the conversion, you have to get Kelvin, you have to take 273.15, add what you're given, so we're given -13, and that gives you 260.15 Kelvin. So that's what I'm going to plug in here. You have to convert this. You can't just put in -13 degrees Celsius. You have to convert it to Kelvin. So that's the number I'm going to use. As long as you remember this conversion factor here, you'll be fine. And you have to remember to convert to Kelvin. Now let's plug in the second part of it. We're finding P2. We don't know what that is yet. And we're given T2. So let's convert that really quick. So 273.15 plus it's 15 degrees Celsius. That is 888.15 degrees Kelvin. That's what I'm going to plug in down here. Now you solve for P2. And when you do the math here, it comes out to 1.66 ATM, same units as before. All right, next question. Container holds 3 gases, oxygen, carbon dioxide, and helium. They give you the partial pressures of each one. So the pressure of oxygen, 2, pressure of CO2 is just 3, and pressure of helium is just 4. What is the total pressure? This is Dalton's law, so you just P total is equal to the pressure of each gas. In this case, we have 3 gases. So all you have to do is add these up. So it just turns out to, you want your total, you just go 2 plus 3 plus 4. So it just comes out to 10 ATM. That's your total pressure. So these problems are really easy, really straightforward. All right, question 5. You're given 2 liters of a gas. Liters is volume, so let's write that out right now. It's collected at 25 degrees Celsius. So there's our temperature. And 745 millimeters of mercury. There's your pressure. What is the volume at standard temperature and pressure? So again, standard temperature and pressure is 273 Kelvin. It's also 0 degrees Celsius. And it's 1 atmosphere, or 760 millimeters of mercury. So that's what it's going to go to. So there, again, we're looking for volume. They're saying to you, what's the volume? So we don't know. The temperature it's going to change to is 0 degrees Celsius. And the pressure it's going to change to is 760 millimeters of mercury, because that's just standard temperature and pressure. It's like a known universal thing. So this is obviously the combined gas law. So the combined gas law, to recall, is just P1 times V1 over T1 is equal to P2 times V2 over T2. So all you have to do is plug in all these numbers here. So our P1 is 745. Oh, and before we get to that, let's convert everything first, and then we'll get to that. So we have to convert the degrees Celsius to Kelvin. So again, all you're doing is adding 273 to this number. Just add them up. So it just comes out 298.15 K. And again, this is just standard temperature and pressure, so it's the same as 273 K because we wrote it up here. So now we can plug all the numbers in. So again, P1 is just 745. V1 is 2. T1 we figured out is 298.15. P2 is 760. V2 we don't know. And T2 is 273 Kelvin. So here you just solve for V2, and you see something close to 1.795, which will just turn into 1.80. And again, we're sticking with the same units that they started with, so since they use liters, we'll keep it in liters. So that's your answer for V2. I hope this was helpful in practicing gas laws.